So today we're talking about simplifying algebraic expressions. Now a major part of that is like terms. Now you might remember that from previous years, like terms. So what are like terms? They are terms which have identical pronumeral parts. Okay, so the pronumeral parts have to be identical, not similar, identical. So let me write some like terms, and then we'll also look at some not like terms, just as a reminder. So let's do EG1. So if I had 2x y squared, which of the following are like terms? Yx squared, 4x squared y, 3y, negative 4y squared x. Okay, so which of these are like terms? If you'd said that one and that one, you'd be correct. So think about this one, is it doesn't matter that the order is different. The pronumeral part is still the same. It's x times by x squared. So x times by x squared. We do usually, though, put the pronumerals in alphabetical order if we can. That is not a like term because we've got the squared on the x there. So that's x squared times by y. That's x times by y squared. Here we've just got y as part of the pronumeral part. So that's why that's not a like term. Okay, maybe one more. Alrighty. Let's think of another number. 5ab. Okay, so what's a like term? We've got 5ab squared, 2a, 7ab, 6a divided by b. Which one here are the like terms? That's right, there's only one here, that one. That one doesn't have the b part, it's only a. This one is a times b squared, which is the one we're comparing to is a times b. And that is 6a divided by b. I don't really want to get into it in year 9, but that actually rewritten is 6a times by b to the negative 1, believe it or not. So that's a bit beyond year 9, but that's one to keep in mind. Okay, so let's think about our next stage of simplifying, and that's where we have to add or subtract like terms. Let's type that in. Add and subtract like terms. Okay. When we add and subtract like terms, we, again, can only add and subtract like terms. Okay? So if something's not a like term, we can't add it together. So you've got to think of these things as different things. It's a bit hard to explain it. I'll do some examples. Okay. So e.g. 3 we're up to. Okay, 5x plus 2y minus 4x plus 7y. Okay, so I've got some like terms here. Now, good first step is to group those like terms. To group the like terms. I might write that at the side here. Step 1. Group like terms. Okay. So we've got 5x take away 4x plus 2y plus 7y. So 5x take away 4x is 1x. Remembering we don't have to write that one. And 2y plus 7y is 9y. Now, like terms, you can add these like terms, and these like terms. You can add them together because they are like terms. You are adding two like things together. There's 2 lots of y here, 7 lots of y here. So together there are 9 lots of y. We have 5 lots of x, and we take away 4 lots of x to be left with 1x. Okay, let's do another one. Okay, so 6x squared minus 4x plus 7x minus 3x squared. So where are my like terms here? Okay, so I'm going to group my like terms. So 6x squared, each like term here is minus 3x squared. And then I've got minus 4x plus 7x. Okay, 6x squared minus 3x squared, I get left with 3 lots of x squared, and negative 4x plus 7x, that's plus 3x. Now, I'm sure some of you who can do that factorising can see how to simplify it a bit more, but I might leave it there. Now, the thing to remember about all of this is that big maths still apply. Do you remember big maths? What does big maths stand for? Oops. Ooh, don't know why that deleted. Okay, that's a bit better. Big maths. Okay, so we're talking brackets, indices, division and multiplication, and addition and subtraction. Now, this all is the order in which we do operations. Order of operations. Now, of course, this means we do brackets first, then any indices. This division and multiplication, we do them at the same time, working from left to right. Addition and subtraction, we do the same time, working left to right. Remember that BIDMAS always applies. I've been asked that question before. Miss, do we have to do BIDMAS? Yes, you always have to do BIDMAS. Okay, so we've done some addition and subtraction of like terms. Let's do some division and multiplication. Now, the thing about division and multiplication, it doesn't only have to be with like terms. We can do it all together. So let's do some examples. E.g., what am I up to? Example 5. Okay, so we've got 5x multiplied by 2y. Okay, now I'll put this line in. This is what you think. You might not always need to write this line. 5 times by 2 times by x times by y. So we end up with 10 times x times y, or 10xy. Okay. Example 6. 3x times by 2x squared. Okay. Now, we've got 3 times 2 times x times by x squared. Now, 3 times 2 is 6. What happens here with the x times x squared? We look at the powers, don't we? And I've got to consider that x is, or this is x to the 1, and this is x to the 2. That is showing that that is actually x times x, isn't it? So it's x times x times x, which is x to the 3, or x cubed. Let's do another one. Let's do a division. So I'll have 10x squared divided by 5x. Okay, let's think about this. I've got here 10 times x squared divided by 5 times x. Now, if I wanted to write that out again as an equivalent, that's 10 times x divided by 5 times x. Okay, so what's 10 divided by 5? 10 divided by 5 is 2. And here I've got x times x divided by one lot of x. So actually here I can cancel out those x there. So I'm left with 2x. You could think of this being, if x was 3, that's like 3 times 3, or let's, 3 squared divided by 3. Well, that's 3 times 3 divided by 3. We know 3 squared is 9. So they sort of cancel out, and that's why you get left with 3. Okay. That's how you get all of that. Okay, so there's a few examples in your book. There's also some examples on MathSpace that you can look at, and I'll see you next time.